industrial agriculture, specifically precision farming and autonomous tractors, which I think has probably the most real-world use cases and affects every one of us, since we're all eating pizza right now. So, there are 8 billion people on this planet, and there's less and less available land to farm. In fact, there's less than 6% of land to farm, to grow crops, wheat, and so forth. This is an industry that can only be solved by robotics and artificial intelligence. In order to yield the maximum and efficient output, there's no other way around it. So some years back in 2018, I had done some work with CNH Industrial. John Deere and CNH Industrial are the two leading companies in this field. They had flown me into the headquarters in Illinois. At the time, I played a bunch of different roles, but primarily a performance data scientist. I was alongside a lot of professionals and leading engineers across robotics, AI, computer vision, data science, DevOps, cloud, mobile, you name it. And this is not easy. It's actually a very, very noble profession because you have to do things efficiently. And how does that happen? Click the wrong button. Bear with me. Click the wrong button. All right. My bad. Sorry, a lot of technical difficulties here, or kinetic difficulties, I don't know.
The front should pass by midday. Based on drainage and when the rain stops, we should be able to start spraying by end of day.
Yeah? Drew on his way back?
He said he was checking on the boys.
And thank you for coming to my lightning talk.
All right, questions for Anthony? Oh, yes, we do have a couple here. Let's go with the gentleman here first, real quick. There you go.
Oh, real quick question. What program did you do that presentation in? Just curious.
Keynote.
All right. Next question.
So, at what stage right now is your enterprise in precision farming right now?
My venture is in medtech and longevity. My company is Ageless AI. This is some work I've done back in 2018. That's as close as I got to real-world robotic applications.
I see. Thank you.
So essentially, these autonomous tractors cost about $250,000. And my role was to do a lot of load testing and performance testing between the satellites. The farm owners will have tablets that control the machines, and all the machines and sensors and everything. So we're talking probably like around 200 APIs that had to do a lot of DDoS attacks essentially until they failed and find the loopholes. I also found some other security loopholes. So I found some, anyone familiar with GPS spoofing? So I kind of told them a security vulnerability where if I gave them the right longitude and latitude coordinates, I could take that cool robot and just, take it over to my farmland and probably trade it in for a yellow Lamborghini or something.
Yeah, actually, so I'm curious, did anybody actually adopt this? Because I used to work on a drone project myself in 2018 with autonomous drones in ag tech, and what I noticed was it was really, the pushback was from the farmers themselves not willing to learn the technology and adopt it. So I'm curious if they actually broke any ground with that.
Let me ask you a question. What size land do these farmers have that you're familiar with?
I don't remember off the top of my head, to be honest.
So when it comes to industrial agriculture scale, we're talking 1,000+ acres. And most of these people are going to be using that. It was pretty much launched 2021, yeah, maybe 2020. But yeah, John Deere, CNH Industrial, you can look him up.
All right, Anthony, thank you. All right, do we have Joe back on? Is he good? Robert? Robert, do we have Joe back on? Not yet? Okay. All right, let's get Kevin. Kevin, robotics EV charging. Ooh, all right. Welcome. And you can use that microphone there. And just do us a favor, give us a little bit about your background, who you are, and what you're doing here.
Sure. My name's Kevin Cameron. I normally work in semiconductors, EDA, tools for chip design, design verification, that kind of stuff. I've been trying to do startups for a number of years. And the current startup I'm looking for people to help me with is robotic EV charging. So this is going to be a small robot. And the idea is that you use a bunch of them and they move energy around for you. So they move solar energy from buildings to cars during the day is the goal. I maybe have somebody signed up to do some robot design. If anybody's interested in programming the robots or software around how we manage a whole pile of robots and watch where people's cars go and try and work out how to make money out of it, that would be good. So if you're at all interested in hearing more about what the plan is, you can find me and ask me questions if nobody wants to ask now. We can dig into detail if people like. You want some more? Yeah. Okay, so the target robot here is like $3,000 in production. Yeah, sorry. Yeah, so the idea is to build a robot at about $3,000 price point, something that looks like a robotic lawnmower in scale, overgrown Roomba. The target market is going to be things like car parks, park and drive kind of thing. If your car's sitting around for the day in the car park, we're going to be picking up energy from the building somewhere and then going to cars and dumping the energy in. Cars probably aren't equipped for this initially, so we'll probably give people a dongle which I'll plug in and it hangs down somewhere, and the robots actually attach wirelessly to that. So we could also do with a power electronics person if anybody does that around here. Anyway, if you look at what's happening with cars, we spend $1 billion a day on gasoline. That's probably going to run into several $100 million of electricity in a decade or two. So my goal is to get as much of that business as possible. So if you want to get in at the start, now's the time to bug me about it.
All right, that's Kevin with robotics EV charging. Question.
Kevin, let me repeat, see if I understand. Are you saying you want to make a robot that's going to go, let's say we're at a parking lot or someplace, the robot comes out to the car,
Yes.
and I'm not, there's nobody there, but I've signed up, let's say from an app or something, and I'm saying I need power, your robot will come over, connect, and deliver?
Yeah, you probably don't even need to sign up much for this. We'll give you a dongle or something, and the robots will just like fill cars during the
the
day.
main point I wanted to understand is, we're not out at the car. Your robot will go out to the car or truck and charge it up and leave without anybody around. Is that the idea?
Yeah, it's fully automatic.
Okay, got it. And how about things like opening the?
We don't do
the
that.
door
So
panel
the secret sauce, so to speak, is wireless connections. So my background is power electronics.
So
we're
you can
using a
deliver all
transformer,
that
but,
power
um,
wirelessly?
Well, 60% of trips are below 6 miles. That's about 5 kilowatt hours of energy. So we're looking at like topping people up over this. So we want people to start off the day with the car half full or something, and we top it up over the day. So when you get home in the evening, the car's full, and then you can use that energy to run your home. Anything spare, we can sell to the grid at that point.
Okay, so it's like a top-off service, but the point is it's wireless.
Yeah. We could do fast charging as well. I mean, it just depends how many robots you want to involve. The idea is it's bucket brigade. If you want more energy moved, you get more robots.
Okay, gotcha. And how far along are you so far?
Have a pending patent, and I have 2 or 3 people on the team.
Do you have a prototype yet?
No.
Okay.
I mean, there's a lot of what they call AMR, autonomous mobile robot platforms. So we'd get one of those, and then I was like talking to somebody today about getting an arm for the wireless connectivity going. So it's mostly subcontracting people to do stuff to get this going, but I will need people to do software and some of the power electronics design.
So for all the parts you need just in developing your prototype, how much do you figure cash you'll need for parts?
I think the minimum viable product's probably somewhere about 400,000 to $500,000 to get something working, and then your problem is like trying to get through UL and things like that.
All right, another question? There was another question? Here you go, hold on.
So the robot has the big battery inside?
No, the idea is the robot only has a small battery, so you're looking like a kilowatt hours worth of energy, or maybe a super cap.
Perfect. All right, that's one more. Oh, here you go.
Just want to confirm, like the wireless charging, is that some technology that you guys are trying to develop, or that's like some other third-party company that may be developing, and you guys want trying to incorporate into it?
I'm going to try and get Resonant Link to do the transformer piece for me. They've got better technology, so it would be like 98-99% efficient going that way. But I haven't managed to get a conversation going with them yet.
All right, Kevin, that should do it. Thank you for robotics EV charging. It's awesome. All right, now, okay, Joe's ready? Robot Fred. Let's go bring on Robot Fred. All right. And again, Joe, before you get started, just a little background.
All set up. Okay, thank you. My name is Joe Bufkin. I'm a mechanical engineer. Most of my time was in Houston, Texas, with NASA and the aerospace business, designing stuff that astronauts use, that kind of thing. So a little bit of propulsion. But I always wanted to build robots, so during the pandemic, I took the opportunity to work on one. This guy here is named Fred. Friendly robot employed domestically. So, of course, NASA, you always got to have acronyms, right? So here's where I started. There's like this. Oh, sorry, I'm always doing that. Here's the base I'd started. I actually had this machine for me, designed and had a machine, and then you see the motors and the wheels. So that's just the base. Whoop. Okay. So here's the motors doing a little bench type test. When I showed this to my daughter, she said, when I showed this to my daughter, she said, looks like you're just spinning your wheels. So, which I thought was great. Here's another view of the superstructure, and you can see some of the 3D printed parts that are going as part of the base. It covers up some of the stuff. And then here is Fred actually navigating in an office. You see he's got a LiDAR on the front there. And I'm using ROS 1 for navigation. It runs on it with the Jetson Nano as the main brain for this thing. And it got where it could navigate a little bit, but as I'll tell later, it needs some work. Here's the robot arm doing some testing with that. I'm going to advance. There you can see the arm, and the arm is moving very slowly right now. It's just controlled directly from the computer. There's a lot of work still involved in getting the arm to work also, and getting it to doing the kinematics, as someone said earlier, which can be very complicated. Luckily, there's programs that can figure all that out for you. Okay, so let me see if I remember how to do this. All right. Okay, so Robot Fred up for adoption. So I'll tell you what that means in a second. Let's see. Okay, Rob, how do I get this to scroll? Let's see. You told me. All right, here we go. Okay, I tell you, the background story on this is I initially designed this to be an assist to caregivers responsible for elderly, providing a remote communication link, a bit of companionship, and some actual help, like maybe go get me something to drink, that kind of thing, using a voice command, which is another thing someone talked about tonight. It's a dual-wheeled robot. He's able to navigate a little bit. Next task is to get the arm working, provide object recognition, navigate. 3 years of work, much development, some money. So the status is the navigation software runs ROS navigation on a Jetson Nano. The arm is in early stages of development, needs a lot of work more to get that going properly. Communication vision software not really started yet. Mechanical problems, arm mount improvements, battery mount, board mounts, many other improvements. Too much to list. I have a whole list on a project management listing. Electrical, install cooling fans. Well, you can read all this. Improve electrical connections. There's just tons of things to do, as you might expect. So why am I here? Okay, what's the deal? Fred needs a purpose and a home. If not found, Fred's going to be moved to storage, to a robot shelter. And so Fred is available for adoption to the right person of the group. I'd be glad to be involved in transition to a good home if you know of one. So if you want to get in touch with me to talk about it, please do. So that's it. Thank you.
All right, Joe. Thank you. Questions. All right, is this question, Joe? Ready? Is this a precursor to the T-1000 Terminator?
I can't talk about that, in this forum. So.
All right. Where's John Connor?
Hi. Actually, I come from a hackerspace in San Francisco called Noisebridge, and I actually am trying to start a robotics group there. I know how to use ROS and with the LiDAR. I'm getting a turtlebot of my own. Would you be open to donating it for hacking or like robot group hacking purposes?
Yeah, get in touch with me and we'll talk about it and see what we can work out. That's a possibility, yes.
Thank you.
Is somebody's robot about to self-destruct? What's going on? Question.
Does it support ROS 2 or only ROS 1?
Right now, it only is running ROS 1. Yeah, ROS 2 would be an upgrade. shouldn't really be a big problem to go to ROS too. Someone that really knows the ROS.
Another question in the front.
Should your robot gain consciousness in the future, how is it going to feel about being put up for public adoption?
I don't know. When I get done with the time machine I'm working on, I'll let you know.
Papa. All right, Joe. One more.
So this is useful for the elderly people to, I mean, it assists them. So is it fast enough to move around, or it is, I mean, you said it is very slow. How it will help to the elderly in case of emergency, they need help, or does it have the power to pull them up, or?
Oh, okay. No, this would not, as designed here, would not have the power to pick someone up. It's basically be able to pick up a glass of water. That's about the strength it would have at this point. And it moves pretty fast. Probably the slowest part will be processing commands to move, that kind of thing. Once it starts moving, it can move pretty fast.
All right, cool. Thank you, Joe.
Thank you.
All right, Fred, bring my beer.
Yeah.
All right, next we have, is that you, Yaga? Yaga, case for Rust. And Yaga, do us a favor, a little background, please. Should be, where'd it go? Oh, there it is, yeah.
I also have a joke. What's on the robot's gravestone? Rust in peace.
Oh, no.
All right, so I'm here to talk about Rust and a little bit about embedded Rust since this robotics themed. My background is worked in software development backend for a few years, companies like Uber and Meta. Currently in between jobs, so hit me up. I learned about Rust when I was at Uber doing SRE work, completely unrelated, and would just read the Rust book when I'm on call, and people would look at me weird. So now that I don't have a job, I can actually do Rust. So another joke is a Rust developer with a job. So so I'm here to talk about a case for embedded Rust. Why would you want to do that? How many of you have not heard of Rust, the programming language? How many of you are okay at it? Okay, how many of you are Rust curious? Okay, good. So Rust is a systems programming language made by Mozilla and now developed by the community. And 1.0 was released about 9 years ago. My current focus in Rust is testing and hardening WebAssembly runtimes. Some of the work involves creating grammar-based fuzzers in Rust and finding obscure bugs in WebAssembly runtimes. So not robotics related. And I came here to Hackadojo for the first time a week ago to the Rust meetup and met Rob, and he said, hey, it would be cool if you can put Rust on this board right here and talk about it next week. So so some buzzwords you might hear about Rust is fast, reliable, productive, pick 3. This tagline sort of captures the essence of Rust being a modern systems programming language. So where you have very good performance, but also easy to use tooling and newer sort of programming language innovations packed into one language. So some technical bits are Rust is a compile language. It's compiled down to machine code, not bytecode. So that means there's no overhead performance penalty of a virtual machine or interpreter. It also has a very strong and expressive type system. So compared to C, which has a static but not expressive or strong type system, you're protected from a lot of runtime bugs. There's also no garbage collector, GC, and no runtime for Rust, while standard Rust does have a very small runtime and initialization code. You can build Rust for embedded without runtime. You can't really talk about embedded development without getting compared to C, so let's look at a couple of things I find Rust to be great at in that context. First is the expressive type system I talked about. Here's a very simple example where you have a option type of none or some, so that would be a thing and a null pointer. So the upside of this is you can never get null pointer dereference sort of type of bug in Rust. And the best thing about Rust compared to C, I think, is the unified dependency management and build system. So what that means is think of it as NPM, but for Rust. So you have easy to write and build modular code in Rust. And for me, it was super easy to get started with embedded development. So it's just a case of cargo add at the board crate, which is STM32F3. And that's how I got started. Another popular language is Python. I know some folks are doing MicroPython right now. Rust's advantage there is it's run much faster than Python with a much smaller memory footprint. So in constrained embedded environments, that's pretty important. Also in Rust, you get neat and relatively new PL features like pattern matching and algebraic data type, like the option type I just mentioned. The result from a static type system is you get fewer runtime exceptions in Rust and Python. One thing that I want to talk about is Rust on the server versus, I just picked Go since I'm familiar with it. I prefer Rust over Go in this kind of environment. I've done server development in both Rust and Go. And one popular reason for people to move from Rust to Go is there's no GC pauses. I've seen that when I was at Uber, where they migrated from Python to Go. GC pause was a big problem for high throughput services. And so similar that you don't have manual memory management in both Rust and Go, but Rust does it sort of statically, and there's no GC tracing in the middle of execution. Yep. And if you're Rust curious, YouTube Considering Rust by John Jensett. He was a PhD candidate at MIT, and I joined Amazon because this guy went to Amazon, and I thought it would be cool to work with him. And then I left without ever having working with him. And also Google the Rust book if you want to get started. That's 5 minutes.
All right. Questions for Yaga? Yaga, is right? Yaga?
Yaga.
Yaga.
Yeah, you got
Yaga. Yaga. Questions?
Is there like an easy mode if I'm doing something where I don't care so much about performance and where I don't have to worry about the data ownership and the move semantics?
Yeah. I say easy mode is just use owned data types everywhere. So for like strings, you use the actual owned string data type and not use a string reference. And you can also get a very similar experience to Go or Python with the atomically reference counted data types like arc. You can wrap things in arcs. ARC, you can look that up.
Another question.
Yeah, so when it comes to Rust, what's the language support like for other embedded platforms beyond the STM32? Because with MicroPython, it's supported on a lot of places.
Right, so theoretically, you can use Rust on any platform that's supported by the LLVM toolchain. So I know that obscure ones like PowerPC, you can also do ARM, obviously. And yeah, talk to me afterwards. Anything on LLVM you should be able to do in Rust.
Okay, one more question in the back. Robot Robert.
I have some boards that have really small chips on there? Do you think we can run Rust on there?
Yeah, so Rust runtime characteristics is very similar to C. So anything you can put C on, sans the LLVM restriction, you can probably put Rust on there. The memory overhead and runtime is close to C.
All right, thank you, Yaga.
Thank you.
That is case for Rust. All right, next we have Balaji coming up on stage, and he's going to be talking about refueling bots. You know, what I like is that so far no one's been sent to the dungeon. Everybody's been staying within the 5 minutes. To the dungeon you go.
Hello, I'm Balaji. I'm in IT as a consultant. I worked in companies like Toyota, Genentech, and where I have seen robotics, actually. I took a tour in Toyota. There I have seen robotics arms making the Lexus cars, which they press and do all the parts. So I got interest in robotics, but I haven't done much in that, but mostly in software, but designing. So one of the idea was using the elephant's design, which is million-year-old design, how to use that for refueling station, like compact gas station, we can say. So you've seen the elephant is trunk is more very strong, and it can be flexible, which can be used for maybe charging hydrogen or electric cars, which can also move and refuel you with the coffee and things like that. So they just making the trunk as the vending machine to give that coffee or refreshing thing. At the same time, the trunk is used for fueling the current hydrogen or electric cars. So it has the card reader and also display screen as the ears we can use to display the different available items, and also the body can be used as a storage of the different beverages, things like that. So it is a compact fueling station on the move. So it kind of may not be fast, but just moves. So it has its meter to display the different design, and also scanner or that another design. So this can be used as a car wash also, because you have seen the elephants, they do the washing thing very better on their own. So it's powerful jet. It can spray and wash. At the same time, it can use its trunk for cleaning liquids, shampoos, and things like that. So it can use its brush as ears, something, and dryer as fans of in the bottom we have the fans. So it can be a car wash station. It is a multi-purpose type of an elephant, we can say. There's an elephant in the room, but it has its purpose. So we can use this as a mechanic helper in a way. It can store the liquid, and it can dispense different fluids according to the mechanics instruction, whether vocal or sign. It can bring all the tools required. So it is another way of using the design of elephant. It can be a robotic nurse which can give kind of saline or giving a display of different results, giving the right tools for the doctor. So yeah, those are the things this can do, but mostly on mechanical side it is more safer because it's a robot. And it is, if we can use the thread, 4 thread can fit its legs, so it is possible to make. So at least we can use that in Burning Man festival. They are using still the elephant. Thank you.
All right, questions for Balaji. I don't know if I would have that in my, if I'm having surgery, Balaji, I don't want that elephant in there, man. Jesus, man.
So the first thing I thought about when I saw the elephant is you fill the elephant with water and you go out into like the Grand Canyon and help out hikers who didn't bring enough water.
Water, yeah. It has capacity for 4 gallons it can drink at a time, so it can swallow a lot of water to transport. That's a good idea.
More questions? All right, Balaji, thank you.
Thank you.
All right, next we have TJ coming up. Woo! All right. TJ, welcome. And do me a favor while you get set up and stuff, and give us a little bit of background of yourself, and definitely take some time to let us know what Noise Bridge is all about. Yeah, what is Noise Bridge? Yeah,
for sure. So the title, which I totally didn't make up in the past 10 minutes for this presentation, is Noise Nav. And the main takeaway of those two things, where's the HDMI? Oh, that's my. There it is, right there. This is? No. There we go. Yeah, main takeaway is the main takeaway is that I'm from Noise Bridge, which is a hackerspace in San Francisco, and I'm essentially re-implementing Nav, the Nav2, like Nav/Nav2 framework with visual only. Yeah. So yeah, I will. Oh, is that the timer? Okay. Oh. Yeah. Let me do that. Yeah, it's a really sick timer. Did you? Whoop. Oh, there we go. I seem to be. All right. So yeah, the idea is to my idea is Noise Nav, which is visual only indoor no robot navigation. So why build a robot? I think it would be cool for a hackerspace to have like a tech fixture, mostly just like a robot that goes around and guides people to the space. I wanted to. I have as my background, I'm a software engineer, but I recently had studied and graduated with robotics, with like computer science with a robotics background, and wanted to get some practical knowledge too, for a potential job. So this was originally presented to a more general AI audience. I'm sure everyone is familiar with this, but for those who don't know, this is what the robot stack looks like. I'm going to be focusing a lot on perception here, since this is like the main goal, and as well as SLAM. So, so SLAM is aka simultaneous localization, is mapping. Is if you're a robot in the space, how do you figure out where you are in the space, like what the space looks like, and where you are inside of it? Two major implementations of this are the Kalman filter and the particle filter. For my plan for this is to use a particle filter setup, just because it's a lot easier and more robust to like movement updates, or like if you don't know that much about movement mechanics, or the movement of the vehicle. Yeah, so basically SLAM was something invented in early 2000s, where you estimate where a position set of landmarks are, and you have there are two steps: the process update, which is basically how far did the robot move, and the sensor update, which is where are you with respect to given set of landmarks. And a lot of people have used this via Nav2. So this slide is basically like a lot of times in order to create a point cloud, it's like we usually use LiDAR. But what if you could use camera data? And the main goal, and like you've probably heard from most people in the robotics group, you've probably heard Musk talk about this. LiDAR is super expensive. People don't need to use LiDAR to navigate in a 3D environment. Why not robots? And indoor navigation means you like don't have a risk of crashing into things on the highway. The major problem is that cameras don't intrinsically have 3D data, so you kind of have to infer it either from a stereo image or from visual odometry. But now there's a lot of updates in deep learning. So for example, they've actually done like deep visual odometry, and some things I saw, like for example, Meta is actually creating something, and Google are both doing visual like AI in robotics, with the Meta especially creating a representation learning, which is basically like encoding an image into a set of bytes that make it easier for robotic, particularly for robotic navigation. Additionally, there's a concept like with April tags and such of using 2D objects for landmark tracking. So yeah, I have a minute left, and I don't want to get sent to the dungeon. So the onboard compute is Raspberry Pi 4B with about 4 gigabytes of RAM. I have a USB camera, and I drive the motors through an H-bridge. And in order to do the heavy lifting, I'm going to go to a onboard computer, which has a 1080 Ti, also running Ubuntu 22.04 and ROS 2. And implementing an ultrasonic array for obstacle avoidance. So far, I have done a lot of the bring up of the robot itself, so it can move around, it can interact with, it can like do a calibration set, and yeah, and I can also like communicate between the Pi and the computer, and because the hardware bring-up is going to be long, I'm currently looking at a TurtleBot 4, and just buying that and using that for, and on parallel trying to develop the sensors like the Encoders Connect and the Raspberry Pi and Arduino. Also, here is the NoiseBridge AI Discord channel. We also on Meetup, and that's my presentation.
All right, TJ, questions?
Yeah, that was awesome. I'm curious what you mean when you say 2D landmark navigation. What I'm imagining when you say that is you mark an X on the ground, and then the robot knows where that X is.
Basically. So are you familiar with April tags?
No.
Okay, so April tags are kind of like QR codes. There is one, a couple down here. This is what an April tag looks like. It's very similar to a QR code, but it's essentially framed in such a way that it's like you can just kind of use like, oh yeah, this set of patterns is the April tag, and then you can actually, because you can put a pretty good pounding box around that, you can figure out where the position of your robot is with respect to this tag. And the idea is with segmentation and like mask RCNN and other thing, or like other like object detection and bounding box stuff being really accurate, you could theoretically do the same thing with any LiDAR. So like if you wanted to do it on this like Hack the Planet logo. So the idea is combining like your traditional mask RCNN with like a autoencoder that can recognize, basically something that can like recognize a distinct image.
One more question. So for now with the camera, do you use like a 2D camera, or you actually want use like a 3D camera, like more expensive ones, or you actually just want like a 2D camera just to scan the tag and then recognize what's the position sort of coming from the camera?
Yeah, so the end goal is to use a 2D camera. Right now, when I talked about, like, for example, getting a Turtlebot, like this, I think the actual like custom built product will have just a 2D camera. Oh yeah.
Can you show it?
The end goal is to have this 2D camera, basically on the robot itself, or like just a simple USB cam, and perhaps have some more, but like use monocular vision. I could use stereo. I might use stereo vision if I think the like 2D point clouds could help with like the visual SLAM algorithm. So yeah, I'll probably start with RGBD and then try and use monocular if possible.
Thank you for coming down from Noisebridge.
Thank you.
All right, one more.
Oh, I should probably.
Yeah.
keep this.
So when you chose April tags as your visual fiducials, did you consider other platforms before you chose April tag, or was that just the one because it's easily supported by OpenCV?
Yeah, I mostly because it's like a big, because it's kind of like a standard for fiduciary tags. That's why I chose it, and it's like compatible with everything. Yeah, but I eventually will want to like use like object detection to have like a custom fiduciary.
All right, TJ, thank you. That was NoiseNav. All right. I'm sorry, Cujo. Sorry. We didn't get anybody, huh? Not today. We got Svet, last speaker. Get him.
Actually, I do have a presentation which name is Artificial Robot in Natural Resources. But because I already have taken 20 minutes of your time, my proposition is to give that place to someone else, more valuable. So anyone want to take and make this speech right now? Startup, anything, anyone want a mic? Because again, I already spoke like enough today. So
it's a free mic.
Anyone take my place?
Going once.
Come on.
Going twice.
Yes.
Oh, we got a runner. Okay. Robotics? We got a robotics
yes.
on the house?
Come.
Come on up. He's good? He's good.
I can't believe that. Guys, that's opportunity. Give your pitch. Yes. Go on. Yes, excellent. So you said it. Yeah, here we go.
What is your name? I don't even. Edward, welcome.
During my undergrad robotics project, so I guess I'll.
Oh, that's awesome. Yeah. Edward's first time. Welcome.
Sorry about that. I was checking out. Let's see. So maybe just to showcase so let's see, maybe I'll start off with the slides. Oh, okay, yeah. So during my undergrad project, I actually worked with Professor Tori Proster and Simon Penny on in UCI on like robotic herd, along with my colleague Peter Cho. Yeah, he actually did most of the programming. I'll be up like back then. I was just really interested, but I'm actually doing this as an art project. So we want to like simulate the movement of herd animals, but
they want to implement like robots. So that's the overview. And then this topic is actually made by the professor, and as our undergrad researcher, we're trying to see how we can adapt this or making this even possible through engineering. Yeah, so our researchers, so we actually came across like back then. There's a algorithm called BIODS, BIODS, by Craig Wright. They actually use it, I think, on more animation based. So actually the code is out there. So from this book, we literally, I think we just copy and pasted some of this. And yeah, it's quite interesting how it's able to simulate flock movement. So they divide it into three. Oh yeah, so over here, thank God I have the notes. Alignment, separations, and cohesion. So alignment is how it heads toward the flock mates to form the group, right, like a swarm. And separation is how they try to steer away, usually from like a predator or something, to avoid collision, right? And cohesion is they try to stay in the same direction or something like that, yeah. And like for some magic, I guess once you put all the vectors together, they form like the swarm movement like in nature. So here's kind of the, I guess, I have the video later, so I'll showcase it later. And yeah, so we use OpenCV to map the robots, the coordinates. We actually got kind of like taught by the professors, like, well, now you're having a God element that tells the robots where the coordinates. So we're like, come on, this isn't as good as we can do. But yeah, we use OpenCV so far to locate where the robots are in a 2D environment. So this is kind of the setup. You see up there, there's this camera, and we actually just tied a balloon. For some reason, it's good for identifying onto the robot. Yeah, and then we just put like Vex robot part, and we did some simulation on it. I have videos. For some reason, it's not working. Yeah, and then I was actually more into the 3D modeling, so I decided like Caribou for the movements and some design. Yeah, I guess let's just hop into the video references if you don't mind. So here's actually the better version of the. So this one includes is done through Unity, and if you can see, like, so the blue dot, we're simulating like the predator. So you see, like, once it tries to chase like the flock, you see it starts to spread out. But eventually, you see when it gets too spread out, they actually go back and form like separate groups, right? And if we try to navigate like the predator and toward the other group, trying to combine together, they will actually know, oh, we're part of this group. So then they start, you see, accumulating together into a group. Yeah, which I find quite interesting. So now the hard part is, how do we get it to work with robots, right? Now, so we did some kind of simulations on like the companions. So this is like kind of the simulation of following the robot. So right now the robot is targeted and has a coordinate system, and over here is like a target that it's supposed to follow, right? And yeah, with all the stupid gyros and I mean all the coordinate system, it tries its hardest. The white part is actually the head, by the way. Yeah, so we did like separate testings on like evades and stuff. Yeah, so but I would say eventually what happened is really that we came down actually just to the basic. We actually just put the projector and then use potentiometer, because for sure the light would work, right? And we put the dark target as the dot. So once we have a white surrounding radius, it actually means like a census light, so it knows how much power to provide to the motor. And we do 2D reaction. Yeah, that's kind of our fail-safe final, because yeah, for some reason the Wi-Fi and stuff, we're all still testing, and it's just not fast enough, I guess. Yeah, I think we're also using like some kind of 18 mega, or, yeah, maybe a little bit Arduino. I'm not sure. Back then, maybe it's not even. Yeah, it's 2016. Yeah, so we did our presentation. Yeah, for our presentation. Yeah, so yeah, I just find this quite interesting. Yeah, any questions? And yeah,
questions? You got another question? You got a question over here?
So, what inspired you to do this? Was this just to mimic what was already out there in nature, or were you trying to find applications for this outside of the lab?
Yeah, so I would say, since this is part of actually in the art department, there's like the mechatronics department. So they actually do try to build their own expressive, we call them like expressive robotics. Some of them like try to follow humans and stuff. It's all done. And I think one of our professor wants to explore like how, the herd movement, but with robots, So we really want to focus more on the aesthetics. And this is kind of just our like research project on like what kind of technologies are there. And we try to, what kind of like algorithms or things we can do to simulate. So of course we started off with using Unity to simulate the 2D. And then once the 2D is done, then we move on to, okay, let's implement the hardware stuff, right, to make it look cool. Because after all, it's the display and presentation that matters the most, especially in art.
Another question.
Would you like to continue working on it with a larger group?
For like, I guess this is more like a hobby project, because I don't know, like, I'm actually right now toward like trying to find a job. To be honest, yeah, I actually recently just returned back to the U.S. after finishing my master's. I'm actually more focusing on the UI UX design, which I find it quite interesting. Like, so maybe eventually, if this can turn into like a human robotic interaction project or things, like, I think I like to explore like how how humans can collaborate with new technologies, especially in different ways.
All right, Edward. Thank you.
Yeah, thank you.
All right. Woo. All right. Well, I don't know what to say. I geeked out. Who else geeked out? Raise your hand. Nobody? Everybody? All right. I nerded out. That was awesome. It was long. It was exhausting, to be honest. But it's awesome. It's so awesome to see you guys all come out here. TJ, thank you again for coming out from Noisebridge. Shout out to Noisebridge. All right, we got Robert, David, Het, Joe, Anthony, Kevin, Yaga, Balaji, TJ, and Svet. All you guys, thank you guys. You guys are awesome. With that said, we're going to wrap it up. What I want to do is move the tennis table, or not the tennis table, the ping pong table out of the way so we can take a group photo. Bring your robotics to the back. I want everybody in the back with the robotics so we can show it off in an awesome big photo there. So with that said, guys, until next Friday, thank you guys for hanging out at Lightning Talks at Hacker Dojo. Woo!